Here is Chapter 3.4, Transformations of Functions, Day 2. Here we are talking about what are called even and odd functions. An even function is when we have symmetry with respect to the y-axis. So it is horizontal symmetry. So we have our y-axis here. We have a parabola. That would be an example of an even function. A parabola where the vertex falls on the y-axis. If you try to move that parabola over somewhere, now it's not symmetrical with respect to the y-axis. So we need to make sure that it is symmetrical with respect to the um, y-axis. And one way to test that is to plug in the negative value of x like we did before um, in chapter 2 where we tested for symmetry. And if we have this example, f of x equals x squared plus 2, well, f of negative x would be the negative value of x squared plus 2. And if we simplify this and we get f of negative x to equal the value of f of positive x, then we have symmetry. Well, negative x, when you square it, becomes positive x. So this is equal to x squared plus 2. So in this case, this example shows symmetry. Okay? When we are talking about odd functions, we have symmetry with respect to the origin, which is also known as rotational symmetry. If you rotate this around, let's see if I could do this and give some kind of example. If I rotate this around, it gives me the same graph. Okay, I still have that curve. I just don't have this drawn perfectly to where it goes through exactly at the origin. But that's what symmetry with respect to the origin means is you rotate it around 180 degrees and it's going to give you the same graph. So this is an odd function. So to test for symmetry, we would plug in negative x, and what we want is an outcome to be the opposite of the entire value function. So if I plug in f of negative x for my function f of x equals 2x cubed, that is 2 times negative x that is being cubed. Well, any negative number to an odd exponent stays negative. So this is kind of like 2 times the negative value of x cubed. Well, 2 times anything negative is going to be negative 2x cubed. So now that that negative number is out in front of the function of the x cubed, it has caused the negative value of what we started with. We had positive 2x cubed, now we have negative 2x cubed. So this is the negative value of f of x. So this is symmetrical. This is an odd function because it is symmetrical with respect to the origin. So odd function. Whereas the other one, because it was symmetrical with respect to the x-axis, this is an even function. Okay? And I believe that's it for anything new for section 3.4.